Hi, hello everyone, and welcome to GoAskNow channel. I'm Saurabh Tiwari, and today we are going to study about first chapter of class 10th mathematics, that is real number. So that's going to be our first part of this chapter. In this class, we are going to study about real numbers, rational and irrational number, decimal expansions, fundamental theorem, HCF and LCM, and exercise 1.1 of NCERT. So what we already know is what are natural numbers, whole number, integer. But let us revise all these concepts once again. Natural numbers are numbers which start from 1 and it goes toward 2, 3, 4, 5, 6 toward infinity. And it is to be noted that infinity itself is not a number. Okay? It's towards infinity. Means there is no end of number. Next is whole number. Whole number starts from 0. The only difference between whole number and natural number is 0. Whole number have 0 and natural number does not have it. Next is integer. Integer is the group of negative of number, 0 and positive of number. So negative, 0 and positive. It can be represented as 0, -1, -2, which starts from minus infinity, and from 0 in right hand side it goes to 1, 2, 3 to infinity. So we can see that there is neither the beginning of number and nor end. Okay. Next is rational number. A rational number is a number which can be represented in the form of P by Q. So Pythagoras was one. He said that everything is number. Everything which exists in nature is a rational number. Okay. So he was the one who talked about rational number, Pythagoras. So we can see that rational number are the number which can be represented in the form of P by Q, where P and Q both are co-prime to each other. Co-prime to each other means this is the lowest form of numerator and denominator. After we diminish numerator and denominator with the help of common factor of P and Q. We can see that if 6 by 8 is divided by 2, we get 3 by 4. But we cannot reduce it to lowest form further because HCF of 3 and 4 is 1. So we can say that 3 and 4 are co-prime to each other, but 6 and 8 are not. Next is irrational number. Irrational number are the number which cannot be written in the form of P by Q. Okay, so we cannot write a number in the P by Q form is known as irrational number. That means that any number in the form of root prime or pi, these all are irrational number. Or we can write any random number 1.010010001 and go on. Okay, so we also cannot write this number in the form of P by Q. So this is also an irrational number. So any number can be placed on the number line is a real number. So we can see that real number is a combination of natural number, whole number, integer, rational number and irrational number. We can also make a tree diagram for it. Real number have rational number and irrational on the other side. Rational number includes integer, whole number, natural number. Other than real number, there is another number known as complex number, which you will be studying in next standard, 11th class. So what we have already learned, that a rational number is a number in the form of p by q, where q should not be 0, and that's a necessity. Necessity means that if there is something 0 upon any numerator, then this is not allowed in mathematics. Divisibility by 0 is not allowed in mathematics. Okay? So we cannot divide any number with 0. So this should not be 0. P by q. So what we can say about rational number is that any number should be in the form of p by q, where p and q both are co-prime to each other, means in its lowest form, and q should not be equal to 0. Okay? So if we say that what is value of 5 by 0, you will say means it's not defined. It's not defined. Okay? So rational number can be written in the form of p by q. So what does p by q shows us? When we write 3 by 2, we get 1.5. When we write 1 by 3, we get 0.333333, a never ending decimal expansion. Okay? When we write 22 by 7, then we get 3.14. Okay, it's neither repeating and nor ending. So from here we get that a rational number when divided, we get 3 type of decimal expansion, that's terminating, non-terminating but reoccurring digits, and non-terminating and non-reoccurring digit. Okay? Non-terminating and non-recurring. So we can classify decimal expansion in 2 main parts, that's terminating and non-terminating. And non-terminating can also be further classified in 2 parts, that's recurring and non-recurring. Okay? So few examples are 1.245, 2.37, 6.7. In recurring we can write 1.77777, 2.35, 35, 35, and non-recurring, that's 1.01001 dash 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 dash. Means it doesn't have any number which repeat itself after decimal. And this comes under irrational number. And these both are rational number. I hope everything is clear. So let's move further. I've already told you about what is irrational number, root 2, root 3, root 5 and pi. These are examples of irrational number. So we are going to classify here the types of number 0.14. What is it? What can you say about this number? This number is First of all, it's rational number and its decimal expansion is non-terminating. Terminating. This one is rational number and its decimal expansion is recurring. Means a number or a set of number is repeating itself indefinitely. Any number, any prime number in square root is itself an irrational number. This is rational number recurring decimal expansion. 272727, these both the digits are repeating itself. Okay. So what we have studied until now? Terminating stops after some digits, non-terminating recurring 0.181818 and non-terminating non-recurring root 2 pi any prime number under square root. Now before we move ahead, we will study about prime numbers. What a prime number is. So prime number is a natural number greater than 1 that has exactly 2 factors. Means it has a set of number more than 2 which can divide the number. Oh. So before we move ahead, we will now study about what are prime numbers. Prime number is a natural number greater than 1 that has exactly 2 factors. Means there are only 2 numbers that can divide that natural number. For example, 2. 2 is divisible by 1 and 2. 3 is divisible by 1 and 2. 4 divisible by 1, 2 and 4. So this is not a prime number. So prime numbers are 2, 3, 5, 7, 11, 13, so on. Okay. Number of prime numbers are infinite. There are infinite numbers of prime number. There is a catch that 2 is the only even prime number. Other than 2, all the prime numbers which exist are odd in nature. What are composite numbers? The composite number are the natural number which has factor more than 2. Means 4. 4 is the smallest composite number because it has 1, 2 and 4 as factor. Means 1, 2 and 4. All the 3 digits can divide 4. Four having the factors 1 to 4, 6 have the factor 1, 2, 3, 6, 9 have the factor 1, 3, 9, 12 have the factor 1, 2, 3, 4, 6 and 12. Okay. 1 is neither prime nor composite and 2 is only even prime number. Now we will study about fundamental theorem of mathematics. This is the reason that we studied about prime numbers in previous slide, okay? Because I know that you have already studied it about prime number in 6th, 7th or 8th classes. It's not a new concept. But to study this, I just revised the concept of prime number. So what are fundamental theorem of arithmetic? Fundamental theorem of arithmetic states that any natural number that exists can be written as the product of prime numbers. Okay. What's that? Suppose 4 is 2 into 2. 3 is 3, or we can write 3 into 1. 6. But we talk here about composite number. Therefore, we will not take 3. So, we will take any composite number. So, any composite number can be written or represented in the form of product of set of prime numbers. Okay. For example, we see that 60. 60 means 2 into 2 into 3 into 5. We can also write is, since 2 appears 2 times, therefore we can write 2 ki power 2, 3 ki power 1, 5 ki power 1. But we usually not write 1 here because we know that 1 already exists. Okay. So there is no need to write 3 ki power 1. We can simply write it 3. So the prime factorization of a natural number is unique except for the order of its factor. What does it mean? It means that the number appear 2 ki power 2, 3 ki power 1 and 5 ki power 1 is unique. But you can also write it as 3 ki power 1 into 2 ki power 2 and 5 ki power 1, means that order can be changed, but numbers are same, set of prime numbers are same. So now we are going to find out HCF and LCM of given two numbers, and that's 6 and 20. Okay, find the LCM and HCF of 6 and 20 by the prime factorization method. So 6 is product of 2 and 3, and 20 is 2 into 2 into 5. For HCF, we will look for the highest common factor, and that's 2. So HCF is 2. For LCM, we will look for least common multiple. And how will we get that? We will get that by writing this 2 ki power 1, 3 ki power 1, 2 ki power 2 and 5 ki power 1. Now we will write all the prime factors that appear. So 2 into 3 into 5, and now we will write maximum power of these numbers. So 2 ki power 2, 3 ki 1 and 5 ki 1. LCM is 60. There is a property related to two numbers and HCF and LCM. And what's that property? Property is for any two number, A and B, okay, its product is equal to its LCM and HCF. For example, let's look behind. That two numbers were 6 and 20, and HCF were 2 and LCM was 60. It's 120 and it's 120, and LHS equal to RHS. Okay. So conclusion is that for any given two number A and B, product of its HCF and LCM will be product of these two number. And this works only for pair of, okay, a pair of number means only for two number, not more than two number, not for 3 numbers and 4 numbers. Now next topic is finding whether a product of number can have 0 at its last digit or not, or how many zeros can be there. For example, for 2 into 5 we get 10, for 2 into 5 into 5 we get 100, for 2 into 5 into 5 we get 50. So we see here that there was single pair of 2 and 5, there is 1 0. There was two pair of 2 and 5, there is 2 0. There is one pair of 2 and 5, then 1 0. Okay. So if there is gonna be n number of pair of 2 and 5, then there will be n number of zeros. Okay. And if we are not getting any number of pair, then we will not get any zero. For example, 2 ki power 4 into 3 ki power 3. Are we getting any pair of 2 and 5? No. Why? Because 5 is not there. So to get 0 at the end of any number, its product should be both 2 and 5. Okay, means there should be product, there should be factor of 2 and 5. Now question is, can 14 ki power n ends with 0? No. Why? Because 5 is absent here. Next is, so if 14 factor of 14 is 2 and 7, 5 is not there, then we can conclude that for 14 ki power n, there will be no 0. Next is, can 20 ki power n end with 0? Yes. Why? Because 20 is 2 ki power 2 into 5 ki power 1. A pair of 2 and 5 is there. Can 15 ki power n ends with 0? So no. Why? Because 2 is not there. 2 is not factor of 15. Now we are going to start exercise. Okay, exercise 1.1. Write each number as a product of its prime factor. And what does this represent? This represents the fundamental theorem of arithmetic, that every number n can be represented as the product of its prime number. So what is 140? 2 into 70. Okay. So 70 can be written as 2 into 35. 35 can be written as 5 into 7. Next is 156. For 156, we can write 2 into 78. 78, 2 into 39. 39 will be 3 into 13. Okay. So this is the product of a prime factor. You are going to do this as homework. Find the LCM and HCF of each pair of integer given below and check or verify whether LCM into HCF is equal to product of two numbers. So for 26 and 91, we will see what? 26 is equal to 2 into 13 and 91 is equal to 7 into 13. HCF is going to be what? 13. And LCM is going to be what? So 2 into 7 into 13 ki power into 13. Now we will verify whether P into Q is equal to HCF into LCM or not. So P is 26, 91 and 13 into 2 into 7 into 13. 13 to the 26, 7 13 the 91 and that's LHS is equal to RHS. Verified. For any two number, product of P and Q is equal to product of its HCF and LCM. Find the LCM and HCF of following group of number using prime factorization method. So 12 is equal to what? 2 into 2 into 3, or we can say that 2 ki power 2 into 3. 15, 3 into 5, 3 ki 1 into 5 ki 1. 21, 3 into 7, 3 ki 1 into 7 ki 1. Now what is HCF? What is common factor? The common factor is 3. And what is LCM? So we will write all the number 2, 3, 5, 7. And now we will write what? Maximum power attained by each numbers. 2 ki power 2, 3 ki power 1, 5 ki 1, 7 ki 1. 5 to the 10 and 21, so 2, 1, 0. Five for the 20, 20 into 20, 4 to 0. 4 to 0 is correct answer. If HCF is this, HCF of these two numbers is 9, then find the LCM of these two numbers. Okay. So we are not going to solve it like finding the prime factorization. We will just verify this property. So LCM is 34 into 657. 22538. 8, 3, 15, 2, 1, 2. Okay, 22538. Okay. Now let's move to next question. Check whether the number 6 to the power n can end with the digit 0 for any natural number. So what we are going to do is we will check what are the factor of 6. So factor of 6 is 2 into 3. There is no 5 among these factors. So we will say that no pair of 2 and 5 are there available. So no 0 will be in the end of 6 to the power n. Whatever be the value of n, whether it be 2, 3, 4, 5, 600,000 or lakh, means whatever the value be n, we are not going to get any number of 0 in solving 6 to the power n. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. Now you have to explain why these both are composite number. What are composite number? What are prime number? I have already taught you. Okay, prime number are the number having exactly 2 factors, and composite number are the number having more than 2 factors. So now we will see that how many factors are there. So 7 into 11 into 13 plus 13. This is a number n, and it has 2 factor, and that's what 1 and n. Okay. Now if we are going to get third factor for this number, then it will be proved that it is a composite number. So we are going to take 13 common from these both. 7 into 11 plus 1. So 13 into 78 is equal to n. So 13 into 78 means 78 have further more factors, that are 2 into 39 means 3 into 13. Okay, so these are the number of factor of this number. Therefore, it is composite. So we can just leave it after this step, that other than this number, 13 is also factor of this number. Okay. Therefore, this is a composite number. For this, we are going to take out what? 5. 5 common. So 5, 7 into 6 into 4 into 3 into 2 into 1 plus 1. So whatever be the value of this number, 5 is also a factor of this. Therefore, this number is also composite, not a prime number. Okay. Now we are going to do our last question. On a circular sport track, Sonia takes 18 minutes to complete one round. Ravi takes 12 minutes to complete one round. If both start together from the same point and move in the same direction, after how many minutes will they meet again at the starting point? Okay, first of all, we will learn about the concept, that what's the idea behind this question. Suppose this is a circle and a boy A takes 2 minutes to cover this distance. Another boy B take 3 minutes, okay, to cover this. So A will cover 2 minutes, one round in 2 minutes, second round in 4 minutes, third round in 6 minutes, fourth round in 8 minutes, so and so. B will cover same distance, first round in 3 minutes, second round in 6 minutes, third round in 9 minutes, fourth in 12 minutes, so and so. We see that 6 is common factor. Okay, 6 is the common multiple in this scenario. So what we are going to do is finding that LCM of 2 and 3. Same idea, same logic is behind this question. That Sonia take 18 minutes to complete one round, Ravi take 12 minutes to complete another round. After how many times will they meet again at the starting point? So it will be LCM of 12 and 18. 12 is 2 into 2 into 3 and 18 is 2 into 3 into 3. LCM is 2 power 2 and 3 power 3, 3 ki power 2. So LCM is 36. After 36 minutes, they will meet together at the starting point. Okay? So we have done first part of first chapter, real number of class 10 mathematics. In this chapter, we learned about what are real number, which includes rational, irrational, then decimal expansion, after that fundamental theorem, application of fundamental theorem were HCF NCL. Most important property, P into Q is equal to HCF into LCM. After that, number raised to the power n, number of 0. Okay. In next class, we are going to study about irrationality of a given number and Euclid division lemma. Okay, and few questions on terminating and non-terminating numbers. So that's all for today. If you have any questions or want to learn with a tutor live, just contact GoAskNow Academy for one-on-one tutoring support. Thank you and have a nice day.